Okay, welcome back everybody. Today's lesson is about proving line segments are perpendicular. This is Mr. Giovanelli with you at Agua Fria. Alright, our essential question. How can we determine if line segments are perpendicular on a coordinate plane? So, building off what we learned about in our last lesson, which was proving that line segments were parallel, today we're going to learn how to prove that they are perpendicular. Alright, here's that same rectangle we've been kind of warming up with every lesson so far in this unit. But here, it's a little bit different. So here I've told you that this is a rectangle and the slopes of each line have been given. So let's kind of analyze these slopes together here. So the slope of AB is given as -3/4. I'm also noticing that the slope of CD is the same. So this is what we would expect, right? That's basically showing from what we already know that these two lines are parallel. And then you'll notice the same relationship happening here, where the slopes of BC and DA are also the same. So we know that these lines are parallel. Well, that's stuff we would already expect. What we're really interested in today is look at the slopes of these intersecting sides here. Do you notice a certain relationship between these numbers, these fractions? You might notice that they're kind of like the reverse of each other. They're reciprocals of each other, and then also one is negative while the other is positive. So if this is a rectangle, we would expect these lines here to meet at 90 degrees. So what we're showing here is that by looking at the slopes, we can actually tell that the lines are 90 degrees. So we're going to get into that here coming up. Let's review really quick. What is perpendicular? Perpendicular lines are lines that intersect at a 90-degree angle. So here line 1 and 2 are perpendicular because they make 90 degrees. What we're interested in this lesson is how can we prove this? So if we're given any set of lines or we know 2 points on those lines, how can we prove that they intersect at 90 degrees? It's not going to be enough just to say, well, it looks like they make 90 degrees. You want to have mathematical proof for it. Okay, let's actually do the math here. So to prove that these are perpendicular, to recognize what we call perpendicularity, let's find the slope of each line. So we're going to use that slope formula that we've used before, and let's do BD first here, which we'll do in blue. So the slope of BD, and remember I like to do the x1, y1, x2, y2 to make sure that you're following along with me here. So we can do -1 minus 2 over 5 minus -1. So that's going to give us -3 on top, and then this becomes a positive 6 on the bottom. Really important for slopes, as you probably noticed, we got to reduce to this lowest fraction we possibly can. So -3/6 is going to be -1/2. Okay, now looking at the slope of AC now, we're going to do the same thing. We're going to do the slope formula, so we'll do 2 minus -4, the y values, and then 4 minus 1, the x values. So on top we're going to get 6 over 3, which if you divide 6 by 3, you get 2. So looking at these two slopes, these two values are what we would call negative reciprocals. So this is actually proof, actually hard proof, that these two lines are perpendicular. So we know for sure they're perpendicular because these two slopes are what we call negative reciprocals. All right, let's add this to our notes. This is known as the perpendicularity criteria. So you can prove lines are perpendicular if their slopes are what we call negative reciprocals. Okay, so I'm going to show you what this means. So negative reciprocal means you flip the sign and you flip the fraction. So both of those things have to happen. Flip the sign, flip the fraction. So I'll show you exactly what I mean. The negative reciprocal of 2/3 would be -3/2. Right? So we switched the 2 and the 3, the numerator and the denominator, then we made a negative. Now, one word on just negatives with fractions, because you're going to be calculating these things with slope. Sometimes you might see something like this. That's still a negative reciprocal. Sometimes in a problem you might see the negative show up here. That's still a negative reciprocal. As long as the negative shows up somewhere on either the top, the bottom, or the side, that's just showing that the value of the fraction is negative. So as long as you flip the sign and flip the fraction, you have a negative reciprocal, and that means that the slopes are perpendicular. All right, let's practice one here, one where we don't have a visual. So we're given that the slope of line CD is negative 1/3. If line A is located at these 2 points, if it has points A and B, how is line AB related to line CD? So let's check it out. Let's figure out the slope of line AB. Slope of AB, and we're going to have 15 over minus 3, excuse me, and then -1 minus -5. So 15 minus 3 is 12. Make that a big plus. All right, 12 over 4. Now, here's something really important. If you just stop right here, you're going to say, well, these lines probably aren't related at all. 12 over 4 is not the same as -1 over 3, and it's not a negative reciprocal. It's really important that you reduce fractions to their lowest form when you're looking for negative reciprocals. So let's think a little deeper here. 12 over 4, well, that's actually just 3, or 3 over 1. And 3 over 1 is, in fact, a negative reciprocal of -1 over 3. So we can say with certainty now that line AB is perpendicular to line CD because their slopes are negative reciprocals. Okay, if you had graphed it, like if you wanted to do Desmos, so I made a straight line with these 2 points, and then to get this line, I put in y equals -1/3 x plus 8, just to show that line with a -1/3 slope. It's just a way to show, like, yeah, you know, this is a pretty good visual to see that these are a 90-degree intersection. You could also count the slope 1, 2, 3 over 1, so you could see that 3 over 1 slope here versus the -1 over 3 slope here. All right, so just a way to get a visual for you visual people out there, but it really still relies on doing the slope formula to prove it mathematically. Okay, let's do a couple practice problems. So line F has a slope of 2/9 and line G has a slope of -9 over 2. Are the lines parallel, perpendicular, or neither? Why don't you pause here, try these on your own. Okay, unpause here. Perpendicular because you have negative reciprocal slopes. Okay, the next one, oops, didn't mean to repeat a 1 there, it should say 2. So number 2 here, line A has a slope of 3 and line B has a slope of 6 over 2. Well, remember, we always want to reduce these, so 6 over 2 is actually just 3. So because they have the same slope, these lines are going to be parallel. All right, why don't you pause here and try this one on your own. You're given a slope, a line with a slope of 3 over 2. There's 6 other slopes shown. You want to find the slopes that intersect line Q at 90 degrees. So what we're looking for are the negative reciprocals. So go ahead, pause here, try this on your own. All right, unpause here. Here are the slopes you should have selected. Whoops, not that one, I apologize. So you should have that one, and that one. This one is probably obvious because it's just the negative reciprocal. This one you had to reduce, you had to divide both by 2. Okay, so if you divide both the top and the bottom by 2, you get -2 over 3. And then here you do the same thing. You divide both the top and the bottom. In this case, the greatest common factor is 6. So you get 2 over -3. And remember, it doesn't matter if the negative's on the top or on the bottom. It's still a negative reciprocal. All right, just a reminder here that knowing the properties of all our quadrilaterals is going to become hugely important for us. So make sure you know all the qualities of these shapes. I just wanted to remind you of that here. All right, so here we're going to have, we're given 4 points on a plane, and we want to figure out if these lines intersect at 90 degrees. So I recommend you plot these on Desmos if you like a visual here. But I'll do the first one for you, and then you can do the next 3. So let's find the slopes, and we're looking for negative reciprocals again to see if they intersect at 90. So the slope of AB, you're going to have 1 minus 3 divided by 4 minus 2. So that's -2 over 2, which if you reduce that fraction is -1. So why don't you pause here and find the slopes of the other 3 lines? Okay, so the math just showed up on the page here. But hopefully you paused and did it on your own. What I want to point out to you is that this is proof that the lines intersect at 90 degrees. The way we can tell is you're seeing the lines that touch, AB and BC, so they share point B, right? So they intersect at B. These are negative reciprocals. Even though, we don't see the full fraction, negative 1 over 1 is the negative reciprocal of 1 over 1, right? And then the same goes down here. So you have lines here that are negative reciprocals of each other, and then you also have opposite sides that are parallel. So you can probably guess what type of shape this is. And if you did want a visual, if you did do that visual and connected the lines here, you can see that this is a rectangle. So what our math showed on the last page is that all these lines here are making 90 degrees because we had the negative reciprocals. We had the proof that they're parallel because they had the same slope. All right. The only thing that we didn't prove is with certainty that the opposite sides are congruent because we didn't do the distance formula. But you could probably see just from these triangles that I just drew that the opposite sides are also going to be congruent. So we're going to get here eventually in a future lesson, but eventually we would be able to prove that this shape is a rectangle. But for today, it was okay just to show that the lines are intersecting at 90 degrees. All right, if you'd like some extra practice with parallel perpendicular slopes, I put some practice problems on IXL. Check the YouTube description. You can also see Google Classroom. And if you're really interested in the why behind why like perpendicular slopes are negative reciprocals, check out this Khan Academy proof that's also linked in the YouTube video. Best of luck on your exit ticket. Hope there are no mistakes in there today. I hope you guys have an awesome day, and thank you.